Hello everyone, this is Micro P11 and this is part 2 on the Scytale-C decoder for the Inmarsat-C satellite system. In part 1, we have discussed about how to install the decoder as an SDRSharp plugin, how to tune to a particular station on a particular Inmarsat-C satellite, and how to decode that station into frames. And in this video, we will look into how we're going to take these frames and we're going to broadcast them to a so-called listener that will further on break down the frames into messages, into charts, into whatever else information we would like to see and we expect to see coming from Inmarsat-C. We will be able to look inside of those frames, and then you will understand why sometimes we have to wait a long time for a message to show up. And in order to do that, this is the setup. We have one computer that it is running the SPI server. So that computer also has a radio and an Inmarsat antenna. And then all that it does is it provides information to the other radios that tune into that server. And we have two more computers. We have one computer here, computer A, where this SDRSharp application runs. And then we have another computer running into a virtual machine where we will have the listener. So the listener, in our case, will not be an actual application, but it will be a small script, a small Python script that will mimic that behavior, just so we will be able to look inside the frames and see how they look like. And then in the next video, again, we will take those frames and then we will actually break them into messages using an actual application. So what I'm going to do is we need to set up the system. And then in order to set up the system, now that we know where the server is, we need to know where the listener is. The listener is in this computer, and every computer in a network is defined by its address, IP address or UDP address, its address. So if I use them interchangeably, that would be fine. And I'm going to run a console on this listener computer. We define this, we designate this as the listener, and its IP address is ipconfig. It's 192.168.223. So in our decoder, we're going to put the UDP address of the listener as 192.168.223, and we will also give a default port. In our case, is 15003, on which this listener is going to listen for broadcasted frames. We're going to start the decoder, and then I'm going to make sure that I'm going to tune this decoder on LES2, and that is the channel, and then we're doing auto tracking so we can stay on the frequency. Maybe one word about this. LES stands for Land Earth Station, also called CES, Coastal Earth Station, and TDM stands for, it's an acronym for how the information is contained within the frames, and it's called time division multiplexing. We might talk a bit about that when we're going to see the frames that we're listening to, how they look like. So now we have a decoder running, and we are broadcasting information over this UDP port towards this address. So now we need to have a listener on that address, and then I'm going to run the Python script that does the listening. So std-c repos UDP, and then we're going to say Python UDP. So now we start the listener, and then let me put this computer close to the other one. So you will see that for every frame that gets broadcasted, there will be the listener will receive that frame and we will see its content. So when this number will increase, we will see a packet here coming up. So that is frame number 7. The packets come a bit faster because there is whatever processing happens there and the UI is a bit further behind. But what I want you to see is that these frames are mostly filled with zeros. So the information that is coming into these frames is very sparse. The information comes in bursts, and usually it comes at the beginning of the hour or during some periods of intense activity, and when the weather bulletins are coming, for example. And then you will see like a lot of numbers in here because all these frames will be filled with information. But because they're mostly empty, this is why we have to wait sometimes a long time for a message to be displayed in our interface. And another thing that I would like to mention is that every single frame contains this sequence at the end. And this sequence uniquely identifies the decoder that sends this information, which means that we can have any number of decoders running at any given time, and our listener will be able to put the information coming from frames coming from different decoders together and present it as it should be. It will be linked together the proper way. So I'm going to stop this now, and I'm going to stop the broadcaster for a second, and I will start another broadcaster which is running on the same computer where the listener is. I just stopped the listener. I'm going to run it again. std-c repos/udp. And then in this particular listener, we're using the same broadcast address as the one that the listener is listening to, and we are using the same port. We're using the same port on 2 different machines, and you can use the same port on as many machines as you want or as many decoders you want, because you saw how sparse the information is. It comes every 8 something seconds, and there's plenty of space in your network to be sending information over the same port. You can change the ports as well, and we can talk about that when we get to the quick UI that allows in its configuration to have multiple ports. But not to worry, for whatever you would need, 1 port would be enough, I would say. So let's start this one, and then we're going to tune this not on an LES station, but on the NCS station. The NCS station is unique on every satellite, on every Inmarsat-C satellite, and it's called Network Coordinating Station. And this is the one that actually sends all those weather bulletins and pirating activity. And this is also the station that coordinates all the mobile receivers, like the ships that are on the oceans, and it tells the radios on those ships, listen to this frequency, transmit on that frequency. So all the goodies are coming on this one, on the NCS. All the private messages are coming on the LES. So we're going to tune onto this NCS station. Usually the NCS stations are found at the beginning or at the end of the spectrum for the Inmarsat-C. So let's tune into this, and let's start decoding it. And then we should see receiving information in our listener as the frames get decoded and broadcasted. Now we're broadcasting into the same computer, but for the sake of how information travels, the computer doesn't really care. And you see that this particular station has an ID that starts with 7C. So I'm going to run again this one. and then we will see that we will receive at the same time information coming from the two stations. And as I have mentioned, we can have information coming from many other stations at the same time. I think the reason we don't see this information is because I clicked into this Python application and it just doesn't work the way I would like it to. So I'll be more careful. Let me run it again. And this time we're not going to click on it. We're just going to let it show what it receives. And then we will see that this one is the 7C and this one is the AC. So we can tell that there's not much information. We can also tell that one frame comes from one station decoder, one frame comes from a different station decoder. And this is basically how we can see that we have now a full chain of communication. We are able to tune into the station. We are able to decode the particular station. We are able to broadcast the decoded frame towards our listener. And then we can display the information that we listen to. And we have a bit of insight regarding how that information comes with data. And you see this one has a bit more data in it than that one. And then we will discuss more about this in part number 3. So thank you everyone for tuning into this video, and then looking forward to see you again in part 3. Goodbye.